Reverse Mercator sailings are going to be the bane of your existence. They're also completely unrealistic. So a reverse Mercator, or I'll back up. A normal Mercator sailing, like we just learned, is when you're given a departure point and an arrival point and told, you're here, you want to be here. What is your course and distance to get from here to here? A reverse Mercator sailing is when you're told, you're here, go this far in this direction. Where will you end up? What will the coordinates of your end point be if you follow this track for this far at this course? It's completely unrealistic. There's literally no situation, any type of ship, whatever its profession may be, where you would be instructed by, I suppose, your CEO, hey, I need you to sail this far in this direction for no particular reason. Like, you can't change course. It has to be this way for a given distance. And I need you to find where we will end up at the end. It's insane. The reason we do it, though, is if you can do this problem in reverse, you can do it forward. Being able to do a reverse Mercator sailing is just a demonstration that you've mastered the concept enough that it doesn't bother you to do all the equations backwards, even if it's for a meaningless objective. So here's our question. You start at 15 degrees north, 070 degrees, 10 minutes west, and you need to sail 930 nautical miles on a course of 262. Why? I don't know. But you need to sail there, and you need to find where will your end point be. So, what do we need to begin with? Well, you're still using the same equations. So you're still going to need difference of latitude. You're still going to need difference of longitude. You're still going to need meridional parts. But you don't have that. You don't have any of that. What you have is your course and your distance. So you can't even touch this equation yet, but you can touch this one because you have D. D is 930. And you don't have CA, but you have CN. You have, your CN is 262. So, everyone's favorite, we get to draw the diagram again. CN is equal to CA. CN is equal to 180 minus CA. CN is equal to 180 plus CA. CN is equal to 360 minus CA. Which quadrant are we in? We're going on course 262. 262 is that way. It's closer to that way, but it is still in the southwest. So we're using this equation. CN is equal to 180 plus CA, but instead of having CA and adding it to 180, we have CN. So we have 262 is equal to 180 plus our course angle. We have to work this backwards because this is a reverse sailing. We have to work everything backwards to find our answer. So now we do 262 minus 180. 262 minus 180. We get 82. So our course angle is 82 degrees. What's the sign? You're not going to be asked the sign in the final answer, but you should always put the notation of the sign just to not confuse yourself. We're going southwest, so our notation is south 82 degrees west. Even though it's south 82 degrees west, always remember to read it as 82 degrees west of south. So 1, 2, 3 is how you picture it in your head, even though you read it as 1, 2, 3, south 82 degrees west. So now we have CA. So we can go to our first equation. Distance is 930 is equal to difference of latitude divided by the cosine of CA, which is 82. So if we move this around, what it means is difference of latitude is equal to 930 times the cosine of 82. So that's what we're going to do. Cosine of 82 times 930 equals our difference of latitude. So difference of latitude is equal to 129.4. What is the unit here? What's the unit we always use for DLAT? It's minutes. So our difference of latitude is 129.4 minutes. Now we can actually find half of our answer, because our answer is find our end point, our destination, if we go this far in this direction from this starting point. So now that we have the difference of latitude, we can apply that to the starting latitude and find that portion of the answer. To do that, though, we can't have it all in minutes. We have to convert it to minutes and seconds, or degrees and minutes, I'm sorry. Meaning, you divide this by 60, you cut out the whole numbers, you leave the remainder, you multiply it by 60 again, and that will give you your degrees and your minutes. Now, I can already see in my head that this is 2 degrees, 9.4 minutes, but let's practice that. 129.4 divided by 60 minus 2 times 60, 9.4. So our difference of latitude is 2 degrees, 9.4, leading zeros on both, minutes. Are we going north or south? We're going south. So when we put that together, we have to take 15 degrees, 20 minutes north. And imagine we're headed down. You can think of it as finding the difference of latitude between the two, but that's going to confuse you. Just think you're going down 2 degrees and 9 minutes. So now you subtract the two. 20 minus 9.4 is 10.6. And 15 minus 2 is 13. So our end point, I'll put it off to the side here, has a latitude of 13 degrees, 10.6 minutes north. This is also really important because now to move on to the next step, we need we're looking for a difference of longitude, but we need meridional parts to do it. And we need our ending point to be able to calculate its meridional parts. So now we're going to find the meridional parts of both the departure latitude and the arrival latitude. So we come back about it, open it up to 667 or table 6, whatever is true for your book. Here's meridional parts. First, we're going to find 15 degrees, 20 minutes. So that's over on this side. So I'll move you. 15 degrees is this column. 20 minutes is right here. So you follow the column down. 925.1. So you come back to the paper and write for M 925.1 for M1, and then for M2 we're looking for 13 degrees 10.6 minutes. Now that's a good point. I haven't talked about that yet, but here's 13 degrees. Here's 10. There is no 10.6. This is only accurate to 1 minute. So what do we do if we need to find 0.6 minutes between 10 and 11? Well, if you look over here, the difference between 13 degrees 10 and 13 degrees 11 is 1, exactly 1. It's not normally that precise, but in this case, it's literally just 1 additional meridional part. So that's small enough that if you wanted to, you could just round 10.6 to 11 and use 92.8. Additionally, you could say, well, it's a little more than halfway between the two. So you can just, in your head, add 0.6 right there, and that would get you 2.4, and say that the value for 13 degrees 10.6 is 792.4. It's not perfect, however, this is such a small difference. 792.4. We're talking about such a small difference in this number, it barely makes, it's not going to have an impact. It's going to have essentially no impact, especially because when you're sailing in the end, you're probably going to be rounding your course to 1/10 of a degree, meaning there's no reason to expect to stress over, a matter of tenths of meridional parts that are going to be put into this equation. So now we have our two meridional parts. We are going south from a more northerly position, so we subtract these two. So we take 925.1 minus 792.4. You get 132.7. So your difference of meridional parts is 132.7. Now we can come on to our last equation. So tangent of C, or CA, we know CA is 82, is equal to our difference of longitude divided by our difference of meridional parts, which is 132.7. So now again, we can take this tangent and multiply it across to 132, and that will give you our difference of longitude. So tangent of 82 times 132.7, 944.2. So our difference of longitude is 944.2 minutes. Now we have to convert this to a value in degrees a minute so we can actually apply it to our starting longitude. So first, as always, divide by 60. 944.2 divided by 60. 15.7. You subtract the 15. Then you multiply the remainder by 60 again. You get 44.2. So our difference of longitude is equal to 15 degrees, 44.2 minutes. So that's what we can apply to our starting longitude. So our starting longitude is 070 degrees, 10 minutes west. And we're moving 15 degrees, 44.2 minutes west. We're going west because we're going on a southwesterly course. So we're adding these two together. Don't get confused by the idea of same name, subtract, different name, add. That's true if we're finding the distances between 2 points, but this isn't a location. This is a direction and distance. We're moving this far and we're finding where we will end up. So in that case, we can add it together. So 10 plus 44.2 is 54.2. 70 plus 15 is 85. So our final answer is, if we start at 15 degrees, 20 minutes north, and 070 degrees, 10 minutes west, and we went 930 nautical miles on a course of 262, we would end at 13 degrees, 10.6 minutes north, and 085 degrees, 54.2 minutes west. And we know this with a high degree of accuracy because unlike a mid-latitude sailing, we are actually constantly accounting for the change in meridional parts along that slope, along that curve that we're following, with enough accuracy that we can say that this really is where we will be, ignoring current and wind and whatever other factors might push you off course. But if you actually stuck on course, you would get this answer. Remember, these are not realistic, but they will be something you're tested on. I guarantee it.